Again, continuing on with arithmetic sequences, solving for the number of terms in a sequence. So, given this example, how many terms are there in the following sequence? -3, 2, 7, comma, dot, 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 all the way to 152. So what we want to do is, again, first look at the sequence and identify everything that we know. So we are given our first term, which is a -3. Looking at this sequence, we could figure out the common difference. So we went from a -3 to a +2, and then a +2 to a +7. So our common difference here would be 5. We also know this last term of the sequence. So even though I don't know the term number, which would be this, that's what I'm looking for. I'm figuring out what term number this is in the sequence. So rather than writing a number here, I'm going to leave this as T of n, which essentially represents the general term or the last term. So now we're going to substitute all the information that we know into our arithmetic sequence formula. We know the last term of this sequence. Remember, this T of n is a general term which can represent any term in the sequence. So I'm going to substitute this last term in the sequence so I can determine what term number it is in the sequence. So I'm going to substitute 152 here. I'm going to substitute a -3 into my first term. I'm going to substitute a 5 in for my common difference. And I'm going to leave n as is because I don't know that. That is what I am looking for. So now I'm going to rearrange this equation to solve for n. And I know most of you are most comfortable of running this through the brackets, but I'm going to solve it a slightly different way. Rather than running this through the brackets, I am going to move this -3 to this side of the equation first. So the opposite of minusing 3 is I'm going to add 3 to both sides, which leaves me with 155, and those are going to cancel each other out. And then we have this n minus 1 times 5. And because this is a multiplication statement, I'm now going to move the 5 to this side of the equation by dividing both sides of my equation by 5. So those cancel. And I get a value of 31 when I divide that. And now all I'm left with is this n minus 1. And then to solve for my n value, I'm obviously going to add 1 to both sides. And I get a value of n equals 32. So how many terms are in the sequence? There are 32 terms in the sequence. Or you can think of this 152 as term number 32.